Hello dear children, and welcome all of you to the class of mathematics. We started chapter number 3, that is pair of linear equations in two variables. We discussed that ax plus by plus c is equal to 0 is the standard form of linear equation in two variables. We also discussed that when we are given two equations together, they are called as simultaneous equations. In today's video lesson, we are going to continue with this topic and we are going to solve some of the examples. So here we go. We are going to begin with exercise 3.2. Exercise 3.1 we will take little later. So this is first question from exercise 3.2. Form the pair of linear equations of the following problems and find their solutions graphically. In this, your first example is 10 students of class 10 took part in a mathematics quiz. If the number of girls is 4 more than number of boys, find the number of boys and girls who took part in the quiz. So like how we are reading the sum, we have to consider x and y for the given statements. So we will consider number of girls who took part in quiz be x and number of boys be y. Total number of students are 10, so we will write it in the form of equation as x plus y is equal to 10. If we read the second statement, it says that number of girls is 4 more than number of boys. So we'll try to write this in terms of an equation that number of girls is equal to number of boys, but girls are 4 more than the boys, so we'll write it in this manner. In terms of equation, since we have taken number of girls as x and number of boys as y, we will write it in this manner. So our second equation is x minus y is equal to 4. Now we have got two equations and we have to solve these two equations in the form of graph, or graphically we have to find this out. So when we have to solve the equations graphically, we need the coordinates. So let's try finding the coordinates for both the equations. We'll start with equation 1, x plus y is equal to 10. Keep in mind that when we have to find out the coordinates, we'll try to keep y towards the left of the equation and shift all the terms towards the right. This is not compulsory, but by doing so, we are making our sum simple to find the coordinates. So in our case, I am writing y is equal to 10 minus x. To find the coordinates, I'll form a table. So in the table, you are writing x and y. Our equation is y is equal to 10 minus x. Now in place of x, I can substitute the values of my choice. So you have a choice to substitute from 0 to negative numbers to positive numbers to integers, but substitute the values in such a manner that you will get proper coordinates. So we are substituting x is equal to 5, so we get y is equal to 5. So our first coordinate is 5, 5. Then we are substituting x is equal to 6. If you substitute x is equal to 6, we get the value of y as 10 minus 6, which is 4. So the second coordinate is 6, 4. Now it is more than enough to find two coordinates to draw a line passing through that. So we'll move to the next equation. Our next equation is x minus y is equal to 4. And as I said, we'll try to keep y towards the left. So our equation is y is equal to x minus 4. In the table, again we will write x and the y coordinate, but y is equal to x minus 4. Try substituting the value of x here, that is of your choice. We are substituting x is equal to 4 first. So by doing so, we get the value of y as 0. So our first coordinate is 4, 0. Now you have a choice of substituting the value of x of your choice. I have taken x is equal to 5. So by doing or substituting the value of x as 5, we get y is equal to 1. So the next coordinate is 5, 1. Now we have got the coordinates for the second equation also. Let's plot it on the graph. Now when you draw the graph, your first thing which you're doing is drawing x and y axis and writing x dash, y dash, and then you will start plotting the points. Looking at the first table, our first point is 5, 5. So 5 is x coordinate and 5 is y coordinate, so the point will come here. Then we have 6, 4. You will plot it like this and then draw a line passing through these 2 points. Considering the second table, we have the coordinates 4, 0, which will come here, and 5, 1, which will come here, and a line passing through these 2 points, it will be this. Both the lines intersect each other at this particular point, and this point is 7, 3. And this particular point is our solution of the equations. Once you draw the graph, do not forget to write the equation for that particular line. So we'll be writing x plus y is equal to 10 for the green line and x minus y is equal to 4 for the other line. So from the graph, we got our answer as x is equal to 7 and y is equal to 3 is the solution of the given condition or given sum. X is number of girls, y is number of boys. So 7 girls and 3 boys, and we know that total number of children taking part in the quiz is equal to 10. So our sum is correct. Moving to the next sum. 5 pencils and 7 pens together cost rupees 50, whereas 7 pencils and 5 pens costs together rupees 46. Find the cost of 1 pencil and that of 1 pen. Since we have to find cost of 1 pencil and 1 pen, we will consider price of 1 pencil as x and that of 1 pen as y. Alright, now according to the condition, we have 5 pencils and 7 pen and the cost is 50. So we'll write it like this: 5 into cost of 1 pencil plus 7 into cost of 1 pen is equal to 0. But cost of pencil we have taken as x and cost of 1 pen we have taken as y. So our equation will be 5x plus 7y is equal to 50. We'll consider this as equation 1. Second condition is 7 pencils and 5 pens costs rupees 46. So your second equation will be 7x plus 5y is equal to 46. And now we have 2 equations to solve graphically so that we can find the value of x and y. So let's start doing that. We have to draw the table. For that, as I said, we'll consider first equation 5x plus 7y is equal to 50. I said we'll try keeping y towards the left side and shift all the terms towards the right. So our equation will be 7y is equal to 50 minus 5x, and therefore y is equal to 50 minus 5x upon 7. Let's try drawing the table and find the coordinates. So we have x coordinate and y coordinate. Now when you have the value of y in the form of fraction, you have to be very careful in selecting the values of x. This is because you will select the values in such a manner that y coordinate should not come in decimal points or it should not come in fraction. So when we select the value of x as 3, what do we get? We get 50 minus 5 into 3 is 15. So 50 minus 15 upon 7. 50 minus 15 is 35 and 35 upon 7 is 5. Alright. Then if we substitute x is equal to minus 4, then what do we get? Y is equal to 50 minus 5 into minus 4 is minus 20. Minus minus will become plus. So you get 50 plus 20, that is 70 upon 7, and 70 upon 7 is 10. So we get two coordinates, that is 3, 5 and -4, 10. Alright, then we will consider our second equation, and the second equation is 7x plus 5y is equal to 46. Then we'll write it in such a manner that y will be towards the left, so 5y is equal to 46 minus 7x, so y is equal to 46 minus 7x upon 5. Then we will try drawing the table and find the coordinates. Now here also you should be very careful when you will select the value of x, because we do not want our y coordinate in terms of decimal point and fraction, because when you plot it on the graph it becomes difficult to plot the point. So when you substitute x is equal to 3, we get 46 minus 7 into 3 is 21. So 46 minus 21 is 25, and 25 upon 5 is 5. Then if you substitute x as 8, we get 46 minus 7, 8s are 56, and 46 minus 56 is minus 10, and minus 10 upon 5 is minus 2. So we get the value of y as minus 2. Hence our two coordinates are 3 minus 3, 5 and 8, minus 2. Now we have coordinates of both the equations. Let's try plotting it. First coordinate is 3, 5, and you will plot it like this. Second coordinate is minus 4, 10. Look here on the graph paper. Minus 4 is towards the left side of the origin, and here the point is. Then we'll draw a line passing through both the points. Next point for the second equation is 3, 5. So here it comes. And next coordinate is 8 minus 2, and 8 minus 2 will come in the fourth quadrant in this manner. We'll draw a line passing through these 2 points also, and we'll observe that both the lines intersect each other at this particular point, and that is 3, 5. As I said, do not forget to write the equations on the line in this manner. So we get the answer, and our answer is x is equal to 3 and y is equal to 5 is the solution of the equation. We have taken cost of one pencil as x and cost of one pen as y. So cost of one pencil is rupees 3 and that of pen is rupees 5. Alright, so this is how we have to find the equations or the solution of the equation graphically. Now this is exercise 3.2, question number 2 and 3 combined we are taking. Question is on comparing the ratios A1 upon A2, B1 upon B2 and C1 upon C2, find out whether the lines representing the following pair of linear equations intersect at a point, are they parallel or coincident, and also find out whether the equations are consistent or inconsistent. So you are given this as your equation number 1, but before we proceed, before we solve this equation, I want all of you to have a look at this particular slide, which will give you an idea about the graphical interpretation of the equations. Now, if you compare the given equations with the standard form, and if you get the ratios of A1 upon A2 and B1 upon B2 not equal to each other, the graphical interpretation or the graph of the equations will be intersecting lines, and when the lines intersect each other, the given pair of linear equation will have only one solution. If we get all the three ratios equal to each other, that means our lines, when we will draw the graph of both the equations, both the lines will overlap each other. They will coincide with each other, and that means that both the equations, they have got infinite number of solution. And if we get our ratios in this manner, A1 upon A2 is equal to B1 upon B2, but it is not equal to C1 upon C2, then on the graph we will get parallel lines. That means the given pair of linear equation do not have common solution. So this is the note for you, and based on this note, now we will solve our sum. So this is what is exercise 3.2, question number 2, and from question number 2, this is first sum. We'll consider both the equations as 1 and 2 and compare both the equations with the standard form, that is A1 upon x plus B1 upon y plus C1 is equal to 0. And for the second equation, we'll consider A2x plus B2y plus C2 is equal to 0. If you compare equation 1 with its standard form, we get the value of A1 as 5, B1 as -4 and C1 as 8. In the same manner, for equation 2, we'll get A2 is equal to 7, B2 as 6 and C2 as -9. Please keep in mind, do not forget to see whether the coefficient has negative sign or not. Once you write this, let's find out the ratios. A1 upon A2 is equal to 5 by 7. B1 upon B2 is equal to -4 upon 6. We'll reduce it to lower terms and it is -2 by 3. And C1 upon C2, you get that as 8 upon -9. Now, if you observe, what do we see here? A1 upon A2 and B1 upon B2, they're not equal to each other. And if that is the case, if A1 upon A2 not equal to B1 upon B2, then the equations have one solution, that is unique solution. And unique solution means, how do the lines look like? They'll intersect each other. When you get some solution for the pair of linear equation, we call that, pair of linear equation as consistent. So we say that the given pair of linear equations are consistent. So this is how you have to interpret the result without drawing the graph. And these are very simple sums, and usually they come in the exam for 2 marks. So let's go and move towards the next sum. Our next sum is this. So we'll consider 9x plus 3y plus 12 is equal to 0 as equation 1, and 18x plus 6y plus 24 is equal to 0 as equation 2. Very, very important note that you may be given the equation in any format. You may be given the constant terms towards the right side. Always keep in mind that your equation should always be in the form ax plus by plus c is equal to 0. You will shift the constant terms or constant term towards left and equate it with is equal to 0. Now comparing this equation 1 with its standard form, that is a1x plus b1y plus c1 is equal to 0, we get the value of a1 as 9, b1 as 3, c1 as 12. Similarly, for the second equation we get a2 as 18, b2 as 6 and c2 as 24. Now let's find out the ratios. a1 upon a2 is equal to 9 by 18. Reducing it to the lower term, we get 1 by 2. b1 upon b2, we get 3 by 6, that is equal to 1 by 2. And c1 upon c2, we get 12 upon 24, which is equal to again 1 by 2. So looking at the three ratios, all the three ratios are equal to each other. And when they are equal to each other, the equations have infinite number of solutions. And how do the graph look like? The graph will be the overlapping lines, or you can say coincident lines. And as I said, when you are getting the equations for the given pair of linear equations, we call those pair of linear equations as consistent. So the given pair of linear equations are consistent. Okay, moving to the next sum. In this sum, we'll consider 6x minus 3y plus 10 is equal to 0 as equation 1, and 2x minus y plus 9 is equal to 0 as equation 2. Again, comparing equation 1 with its standard form, we get a1 is equal to 6, b1 is equal to minus 3 and c1 is equal to 10. Similarly, for equation 2, we get a2 is equal to 2, b2 is equal to minus 1 and c2 is equal to 9. Okay, now let's consider the ratios. a1 upon a2 is equal to 6 upon 2 and 6 upon 2 is 3. b1 upon b2 is minus 3 upon minus 1, so that is also equal to 3. And c1 upon c2 is 10 upon 9. So from these three ratios, we get to know that two ratios are equal to each other, but it is not equal to the third ratio. So we get a1 upon a2 is equal to b1 upon b2. It is not equal to c1 upon c2, and its meaning is the equations have no solution. Meaning is that the lines will look parallel to each other, and when the pair of linear equations do not have any solution, we call them as inconsistent. So the given pair of linear equations are inconsistent. So this is how we have to solve the sums. Alright, important sums, but you have to be very careful. Now when the fraction comes, you become nervous, but there is no need to become nervous. We'll consider this as equation 1 and this is equation 2. Comparing equation 1 with the standard form, we get a1 is equal to 3 by 2, b1 is equal to 5 upon 3 and c1 is equal to minus 7. Similarly, our equation 2 will be a2 is equal to 9, b2 is equal to minus 10 and c2 is equal to minus 14. Now considering the ratios, a1 upon a2 is equal to, a1 is 3 by 2 upon a2 is 9, and by solving this you get 3 upon 9 into 2, that is 1 upon 6. Then b1 upon b2, 5 upon 3 upon minus 10, when you solve it you get minus 1 upon 6. Third ratio, c1 upon c2, and for that you will be writing minus 7 upon minus 14, that is 1 upon 2. What are you getting from this? First ratio and the second ratio are not equal to each other. So we are getting a1 upon a2 which is not equal to b1 upon b2. And what do we interpret from this? That the pair of linear equation, they have unique solution. When they have unique solution means the lines are intersecting lines, and since we are getting a solution, then we'll say that the pair of linear equations are consistent. So this is all about question number 1 and 2 from exercise 3.2. We will continue solving the sums in the next video lesson. Till then, bye and take care.